Hey, all, today we're going to add two more theorems to our flipbook and talk about them, two more ways to show that triangles are congruent without knowing all of their parts. So the next theorem here is the angle-angle-side theorem. And sorry, let me fix this. It should say AAS, angle-angle-side. So if two triangles are congruent, if two pairs of corresponding angles are congruent and one pair of corresponding sides are congruent. So in this example, I have A congruent to L, that's one pair of corresponding angles. I have angle B congruent to angle M, that's a second pair. And then I have side AC and side NL congruent to each other. So I have two angles and one pair of sides. I could also have side CB and side MN congruent to each other, and it would still be angle-angle-side. Now, I'm not saying AB and ML are not congruent, but that is a special type of congruence theorem, which we'll talk about next. So for the angle-angle-side theorem, for this example, we could have the original sides AC and LN, or BC and MN congruent to have angle-angle-side. The next theorem is angle-side-angle, which is kind of a special version of angle-angle-side. We still have two pairs of corresponding angles congruent. So again, I have A and L, and I have B and M, two pairs of corresponding angles. But this time, a special pair of sides are congruent, and those are the included sides. So last time when we talked about side-angle-side, we had included angles, and in this case we have included sides. The sides have to be between the angles we're using. So the included side is the side between the two pairs of congruent angles. So the side in between angle A and angle B, the two angles I'm using to get to angle-side-angle, is side AB. That's my included side. Here, I'm using angle L and angle M to try and get to angle-side-angle, and so my included side would be ML. It's the side that makes those angles. It touches both of those angles. It's between them, and that's why it's called included. So angle-side-angle is a special version of the angle-angle-side theorem. So let's do a couple examples. We really want to be able to determine whether it's angle-angle-side or angle-side-angle. And so again, these things show up where we have vertical angles, or we have the reflexive property. It's going to show up all the time when we're talking about triangles. So right now I have one pair of angles congruent, and I have a pair of sides congruent. Those two sides. And I also, even though it's not drawn, there's no arcs in these two angles, I know that this angle and this angle are both congruent because they're vertical angles. And so now I need to examine, are my green sides between my yellow and my purple marks? And the answer is no. So that means the pair of sides that I have that are congruent to each other are not the included sides. So this is an example of angle-angle-side. In this triangle, I have these two angles congruent. I have two right angles, and so therefore those two angles are congruent to each other because they're both 90 degrees, so they're both the same size. And then I have the reflexive property, which tells me that this side is the same in both triangles. So this purple side, if I were to pull these two triangles apart, this purple side in both triangles would be between the angle that I marked in green and the angle that I marked in blue. So that's the included side, and so therefore this is the angle-side-angle theorem that shows these two triangles congruent. So I want you to pause here. I want you to determine which one of these is angle-angle-side and which one is angle-side-angle. So in this first one on the left, we have the reflexive property showing up here again because I have a side in each triangle that we share. I have these two angles congruent. And I have those two angles congruent. And then I have this side that they share. And if I were to pull both of these triangles apart, that blue side would be between the purple and the green arcs, and so that is the included side, so I have angle-side-angle here. In this one over here, I have one pair of angles marked. I have another pair of angles I know are congruent because of the vertical. They're vertical. And then I have these two sides congruent to each other. So I have two pairs of angles and one pair of sides. This yellow side in this triangle is not between the blue and purple. This yellow side is not between the blue and purple. So this is angle, angle, side. So much like we did with the other three theorems, we can be given two triangles. We can be given the path that we want to take. So I want to use angle, side, angle to show that these two triangles are congruent. And so as it stands, I know that angle W and angle K are congruent to each other. And I also know that these two angles are congruent because they're vertical angles. And so I'm trying to name the piece of information that I would need marked on this picture to be able to say that these two triangles are congruent by angle, side, angle. So right now, I have the two angle pieces knocked out. I have two pairs of congruent angles, and so what I need are the two included sides to be congruent. So the included sides are going to be the sides that are between these purple and green arcs. So in order to show these two triangles congruent by angle, side, angle, then I would need somebody to tell me, or I would need the picture to say that WV, side WV was congruent to side VK. Same idea over here. I have two pairs of angles congruent. I have L and X. I have Y and M. And so that sort of knocks out my two pairs of congruent angles. So I would need to know one pair of sides that are congruent that are not the included sides. So I could say that YZ or MN need to be congruent. Oops, that's my second one I put. Or a totally acceptable answer would be that XZ and LN are congruent. You just have to state one of these two pairs of sides. And notice I did not mention the included side, XY and LM, because we're looking at angle, angle, side, not angle, side, angle. So pause here. I got two for you to try. Name the missing piece of information. What would I have to tell you to be able to prove these by angle, angle, side, and angle, side, angle? So in this first one, I have a pair of angles already marked, and then I have the reflexive property here that tells me a pair of congruent sides. I don't want to have angle, side, angle, so I want to pick the angle that will make this not the included side. Oh, and I've already answered this wrong, so I'm going to answer it right now. I need to know that angle E and angle T are congruent. That would give me angle, angle, side. So this blue side's not between these two angles. This blue side's not between those two angles. And that would give me angle, angle, side. So I would need to know that angle E, whoops, I'll use the regular marker. Angle E is congruent to angle T. Sorry for that mistake. For this one, I have one pair of angles that I know are congruent. I have a pair of sides that I know are congruent, so that knocks out an angle and a side. And since I want this to be angle-side-angle, so I need the included side, so that means that I'm going to say that that angle and that angle right there need to be congruent, and we'll call those VHG or IGH. So I've got 3 for you to try. Copy the pictures, answer the questions, make sure your name's on it, and make sure you give it to me when you're done.